purpose of this video is to provide you with the data needed for my relative mass lab simulation. This is meant to model how chemists actually do count up atoms. They're too small to, pick them out and count them one by one. But this lab will model how chemists go about doing that. So what you see here are different containers with different pieces of hardware of different mass. So you can think of this like our different atoms, our different elements on the periodic table having different mass. And the principle that we're going to work on here is Avogadro's hypothesis. So we're treating each of these containers as if they contained a gas sample. And what we know about gases from Avogadro's hypothesis is that if those containers have the same volume and they're at the same pressure and temperature, we would have the same number of particles inside if it were a gas. So what I've done to model that is I picked a number and I put that many pieces of each type of hardware in each container. You never will open up the containers in this lab and actually count them, but we are going to use that fact that we have the same number of pieces inside as a fundamental piece of information that we need. So we are going to need to measure the mass of each of these samples. And the first step for that is kind of obvious, but one that sometimes gets overlooked. We need to know the mass of an empty container first. And there's a place on your handout to record that right here. So when I place the empty container on the electronic balance, it reads 16.6 grams. We're going to record that here. That measurement matters because we need to subtract out the measure of the mass of the vial or the container for each of our measurements. The small washer is the hardware piece that has the least mass. So it is going to serve the role as hydrogen in this lab. Hydrogen is the least massive element. So let's go ahead and get the measure. For the mass of the small washers plus the vial, we're going to use a value of 34.8. Now that is the mass of the small washers and the container. We need to subtract out 16.6 grams if we want to know the mass of the sample only. We're just subtracting out the container mass each time. So 34.8 minus 16.6 is 18.2. That is going to be the least massive sample. So for the relative mass column, we need to go about comparing each sample to the small washer. The small washer is the smallest. So 18.2 grams compared to itself has a relative mass of 1.0. Now all of the other materials are going to be heavier. They're going to have a relative mass that is greater than 1. At this point, I'm going to measure the mass of the additional samples, and you can record those on your handout. Next up is the medium washer. It might be tough to see, but it is slightly bigger than the small washer. And we want to use the value of 38.2 grams for the total mass vial plus sample for medium washer. You might notice it fluctuating a little bit, and that's just due to the fact that this is not a super accurate scale. That's okay. We'll stick with 38.2. For the large washer, we have 65.9 grams. For the medium hex nut, Let's use 52.6 grams. Let's next measure the mass of the large hex nut sample. And let's record a value of 102.3 grams. Two more samples to go. Let's get the medium bolt. We'll use, reset it here. We'll use 59.1 grams. And then last sample, the large bolt sample. We'll use 134.9. It changed. Let's go with 135.0 grams for the large bolt. So now you should have measurements for each of the samples measured with the container. You want to subtract out 16.6 grams. That's the container mass, the empty container mass, right? We don't care about that. We care about what's inside to get the mass of each sample. Now, the least massive sample was the small washer, because the small washer is the least massive particle. When we figure out the relative mass of the sample, we are actually using our measurements for the group of hardware pieces that is in each container. But because we're saying this fits the model of Avogadro's law, we know that there's the same number of hardware pieces in each container. So although we're directly measuring the relative mass of the samples, we can extrapolate that to say that it's also the relative mass of the individual pieces, okay? Just to review, I put the same number of pieces in each container as if they were gas samples at an equal volume, equal pressure, and equal temperature. From there, you can continue on in the lab and answer the rest of the questions. Good luck.